This video is another right triangle application, only this one involves angle of elevation. So, an angle of elevation is when you're looking at some horizontal and you're looking up. And that angle that it creates as you look to the up at something, that's the angle of elevation. Angle of depression is when you're looking at a horizontal and you look down. And that's the angle of depression, the angle that it makes when you look down. This problem reads, the angle of elevation from a point on the ground to the top of a pyramid is 35 degrees and 30 minutes. So they gave us a nice picture. So they're talking about this point right here. From this point, here's the horizontal and you're looking up to the top, it creates a 35 degree, 30-minute angle. The angle of elevation from a point 135 further back. So if you move back from this point 135 feet and you look up, angle of elevation created is 21 degrees, 10 minutes. So what they ask us to do is find the height of the pyramid. Now the height of the pyramid is the perpendicular dropped from the top of the pyramid to the base, and it creates a right angle, which is helpful to us because we know all about right triangle trig identities. So you can kind of see in this picture two right triangles. You see this one right here that it creates, and then we also see this other bigger one right there. So I'm going to kind of pull those two triangles out here in a minute. Let's think about what we need. We need to find H. I have labeled this distance here X. We don't know what this distance here X is, but it is the base of the smaller triangle. So that's going to become important to us. Let's pull the smaller triangle out. It looks kind of like this. This is our height that we're after, right? The H. And this is X that we don't know, but we do know that this angle is 35 degrees, 30 minutes. What we're going to have to do here is use kind of a system of equations where we get two equations that involve our two unknowns, X and H. And then we can solve for both of those values and eventually get what we're after, which is H. So in this triangle, we want to come up with a trig function that will involve both H and X. And the one that will involve opposite over adjacent, which has the H and the X, is tangent. So we can say that the tangent of 35 degrees, 30 minutes is equal to H over X. That's true. So that is one equation with two of our variables that we need. That's helpful. Let's pull out the bigger triangle here. And it has the same height, H, but its base is X plus 135 feet. This is the base. And this angle right here is 21 degrees, 10 minutes. We want to come up with another equation that involves H and X. And again, tangent, which is opposite over adjacent, will do that for us in this triangle. So we're going to get that the tangent of 21 degrees, 10 minutes is equal to opposite over adjacent, X plus 135. All right, so we have two equations and two unknowns, and now this is just a lot of algebra to solve for these. I'm going to begin over here with this equation, and I want to kill my fraction. You can always kill a fraction by multiplying both sides by the denominator. So the denominator right here is X. I'm going to multiply this side of the equation by X and this side of the equation by X to keep my equation balanced. And so on the right hand side, the X's cancel, and we get that the height is equal to X times the tangent of 35 degrees, 30 minutes. Okay, that is helpful because now I can use substitution and substitute in this expression for H over here for this H in this equation. So I get that the tangent of 21 degrees, 10 minutes is equal to X times the tangent of 35 degrees, 30 minutes over X plus 135. So now why this is helpful is I have one equation with one variable in it, so I can solve this. this is how we'll probably go about solving this. I'm going to, whenever I have a fraction, I like to get rid of it, and you can easily do that by multiplying both sides by the denominator. In this case, the denominator is x plus 135. So I'm going to multiply both sides of my equation by x plus 135. So on this side, x plus 135, x plus 135. On the right, these cancel. On the left, I have x plus 135 times the tangent of 21 degrees 10 minutes is equal to x times the tangent of 35 degrees 30 minutes. Okay. And I want to make sure I'm running out of space, so I'm going to move this problem up here for now and move my algebra in the middle. This is a little bit hard to see, so I'm going to move to pen and hopefully I won't make mistakes. So I have x plus 135 times the tangent of 21 degrees 10 minutes equals to x times the tangent of 35 degrees 30 minutes. Did I write that down right? X plus 135 equals the tangent of 21 degrees 10 minutes equals x tangent 35 degrees 30 minutes. Okay, so I want to solve for x. What I'm going to do is tangent of 21 degrees 10 minutes is simply a number. I'm going to distribute this number to each of these terms. X tangent 21 degrees 30 minutes plus 135 tangent 21 degrees 10 minutes is equal to x tangent 35 degrees 30 minutes. I'm trying to solve for x, so I would like to get my x's on the same side of the equation. I'm going to subtract this guy and move it to the left-hand side over here. So that looks like x tangent 21 degrees 30 minutes minus x tangent 35 degrees 30 minutes is equal to negative 135 tangent 21 degrees 10 minutes. So what I did in this step was move the terms that had the x's in them, everybody to the left. So I subtracted this term right here to the left-hand side. Then I moved any terms that did not have an x in it to the right-hand side. So I subtracted this term to the right-hand side. Now, I have two terms with the x in it. This is a tool that you'll use quite often in pre-calculus and trig and calculus. Factor out your x term. So you just have one x. Then you're left with tangent 21 degrees 30 minutes minus the tangent of 35 degrees 30 minutes is equal to negative 135 tangent of 21 degrees 10 minutes. Now I just have x times 1x. I'm going to divide both sides of this equation by whatever is being multiplied by my x, which is all of this stuff right here. I'm going to divide by tangent 21 degrees 30 minutes minus the tangent of 35 degrees 30 minutes on both sides. On the left hand side, these cancel. So this is what x equals to. So I'm going to use my calculator and put this stuff in. So if I do that, I'll use parentheses, negative 135 tangent, and I'm going to have to use, I'll put in the 21, then use second angle and choose 1 for degree, and then 10, go to second angle, choose 2 for minutes. That's negative 35 tangent of all this. I'm going to close that parentheses to say this is my entire numerator, hit my division button, and open a parentheses and put all of this in the second parentheses to say that's my entire denominator. The tangent of 21 degrees 30 second angle minutes minus tangent 35 second angle degrees 30 second angle minutes and then I close that, and then I close that, saying that's my entire denominator, and hit enter, and it tells me that the x value is about equal to, it should be 160. Did I enter something wrong? Let me see. 3530, 3530. Oh, I started, this should be 10. I entered that wrong. All right, let me do that again real quick. Okay. Negative 135, tangent of 21 degrees, 10 second angle minutes. Close that, divide by, open, tangent 21 degrees, 10 minutes. Close, minus the tangent of 35 degrees, 30 minutes is 160. That's what it's supposed to be, is 160. All right, so that is our value for x. That is great, except we're supposed to be solving for h, and h is equal to x times the tangent of 35 degrees, 30 minutes. So since I have 160 just sitting on my calculator, I'm just going to go ahead and multiply that by the answer times the tangent of 35 degrees, 30 minutes. Oops, let me get that in there right. 30 minutes. And that tells me that h is 114 feet. And that's my answer for that one.